Okay, so we've got this problem here where there are these two wheels and they're going to turn and roll around this circle over here. And there's sort of this intuitive thought that, let's say, if they're going to be rolling at the same rate, so their rate of rotation is the same. And there's an intuitive understanding that, so your circumference here, let's say this rolls you around to this point, and it takes, like, let's say 3 rolls for it to get back, based on the circumference of this, then if these two circles are rolling at the same rate, it's going to roll around once, back to this point, roll around again to that point, roll around again to that point. And because both wheels are moving around the same circle, they'll take the same amount of time to get back. So when you watch what actually happens, you see that the inside circle is actually moving around here much faster than the outside circle. So what's actually happening here? So that intuitive way of thinking about it is actually not a correct way to think about what's going on here. Because although they are rolling around this same surface here, they're doing two things. They're rotating around their own axis and they're also moving around a circle. And the circles that they're moving around, so this one's moving around a circle here, and this one is moving around this circle here. Sorry, my circles are terrible. Now, if you think about a point on the edge, it gets very confusing because they're doing these weird loopy things all around. The only point that kind of stays going in a nice circle is this center point on each of these wheels. So this one is clearly moving a much shorter distance than this one is moving because this one's on the outside and that one's on the inside. So what's actually happening is that the rate of rotation of the wheel determines how fast the wheel moves along this line here. Or for this wheel, it determines how fast it moves along this line here. Because they're rotating at the same speed, they're moving the same distance over a particular time. So let's say one rotation gets this wheel from here all the way to there, then this distance is the same as the distance this wheel will get to move, which is, to there. It's not going to take it to the same point out here. So if we take a look and we start that there, you can see that this was just an estimation, but it's pretty much correct. They've moved the same distance along this line, but obviously this one's moved a larger proportion of the way around this circle than this one's moved. If you want to put maths to actually the different ratios of what they're doing, then what you do is you say this distance here, let's call this thing here y. This is the blue line that they're rolling around, and this is the radius of y. And then we're going to call this distance here the radius of x. Oh, that's not very visible. I'm going to pick a different color. So this is the radius of x. That's also the radius of x. Any distance from here to here, that's the radius of x. That's also the radius of x. So the distance here of this thing, that is ry minus rx, and the distance of this one is ry plus rx. And so then you can work out the ratio of kind of what's this distance out of the circumference of this, which is 2 pi times ry plus rx, versus the ratio of what this is out of this circle, which is 2 pi, the circumference of this circle is 2 pi times ry minus rx. So they have these different radii, which means that this distance is a different proportion. So I guess the main misconception is you kind of imagine cutting one of these wheels and laying the circumference of it out along this line here and cutting this wheel and laying the circumference out along this line here, and you go, oh, it should take the same number of circumferences to get around. But that's just a misconception, because what you actually need to do is cut this circumference and lay it along this circle, and cut this circumference and lay it along this circle to work out where each one will get to. Because the rate of rotation doesn't determine how far along this circle it gets. The rate of rotation determines how quickly the wheels are moving, and where the wheels are moving are along this circle and that circle. P.S. This is what I went through to get to that point.